And welcome back. Now before we delve into the intricacies of the thing at the back there, that's an ESP32 processor, or microcontroller let's say, and an SSD1306 screen, all on the same board. And I approached Banggood and says, hey, how about I'll review this, because it looks like something that I'm sort of doing at the moment. And they said, sure, go ahead. So here it is. But Houston, we have a problem. You can probably see what the problem is straight away, and believe me, I have tried for at least an hour now to get that display to look like it looks in real life, and nothing I do will change that. However, to prove I'm not lying, and the fact that that display really does look like something, this is going to make you laugh, I can show you what it looks like through my camera on my phone. So if I hold up my phone, this is my phone, and point it, now you can see there, okay, it's a bit blurry because I'm a bit too close, but you can see for one thing, it's not flickering, whereas at the top of the picture, you can see it actually flickering quite mad. So I don't know what my phone's doing differently to what my video camera's doing, and believe me, I've tried all the cameras I've got, and I've got 1, 2, 3, 4, 5 cameras, and none of them stop that flickering. So there we are. So that's proof enough, I think, that it's not flickering and it's pin sharp. Something else you probably can't quite make out on that display because it's all a bit blurry. Filming cameras, it's not good, is it? But that's as good as it's going to get. You'll have to take my word for it. Actually, I can do better than that. This is what's coming up in the future bit of the video. Look how stable that display is down the bottom that I'm tapping there, and the top one as well. So we do manage to get it fixed. So keep watching. Right, back to the item in question then. Now, the reason why I was interested in this is because, well, frankly, I made a mistake. When I ordered this, or requested it, let's say, I thought this was an ESP8266, which is what I'm using here in my Home Alone project under here. I don't want to touch this too much because it keeps beeping and things. So there's an ESP8266 Wemos D1 Mini under here. Now made by Lowly, I understand, but whatever. And it's got on it, as it says here, look, OLED shield. And this shield here is very nice indeed. And in fact, if I do move, I know what I can do. I need to shield the light from above. Just a second. There we are. Look, now if I shield that light, you can see that it's a lot easier to read. But I have to say, in real life, it's absolutely pin sharp. Not like that. Even that looks a bit blurred. I've noticed this before, videoing LED type stuff, OLEDs, LCDs. It never works properly. Anyway, that one down there is at least not flickering. Why the two are different? It's the same screen, just a different size. I have no idea. Same library driving it. Different processor, admittedly, but anyway. So that's what I'm using as part of my Home Alone project. And the reason I decided to use that was because I thought, how am I going to tell what's going on with all this? See what I mean about touching things. This touch screen looks a little bit hacky. That's because it is, and that'll be put on a board properly soon, probably on this little development board here, or I'll put another development board over here because I've got the room. But anyway, that was just experimentation, and as you can see, I've set the thing off now. In which case, I might as well pick it up. So the ESP8266 is here. That's an SD card. I think I've shown you all this before. That's a triple base plate down the bottom, all paralleled connections, and yeah, the OLED screen on top. Now this one, I thought, because I thought it was an ESP8266 at the time, I thought, oh, perhaps I could use this as my base unit, if you like, and just add other bits onto some sort of PCB or something, and then just solder the components on there. So, I've just mentioned the magic word, components. Let's have a quick message first. I'd like to give a shout out to LCSC Electronics, China's leading electronics components distributor, who are in fact just sponsoring this video. Our electronic components orders can be picked and shipped in just 4 hours, and you can pay by PayPal, various credit cards, American Express, or even wire transfer. And you don't even have to create an account if you'd prefer not to. Just check out as a guest on their easy-to-use website. If you do decide to create an account though, you can use their new feature of account prepaying. I think I might try that soon. Try out their website now. Right, so as I was saying, I'd sold all the components onto a PCB or something around this, except this is an ESP32, not an 8266. And anyway, by then I was already well into the throes of making this. So I thought, okay, I won't use it on this occasion, but I might use it on another occasion. Now, one of the things this is good for is debugging your program as you're running. Now, of course, when we debug stuff, we all write stuff to the serial port, a bit like this one here. Right, so this is the actual code that's running pretty much. And over here on the right, you'll see all the debug stuff. Now, most of this is in fact sent out by the unit itself, all this reset stuff. Yeah, so I'm sending out Wi-Fi connected, blah de blah, the date, time. Is that the right time? Oh, that's about half an hour ago. And forget that little message down there. I was experimenting with null pointers in C++. Okay, ignore that. But the point is, when you're debugging stuff and you just want a few things up on there, that's absolutely fine. It's a good way to do it, and you can get your code to a nice state much quicker. However, what though if you want the occasional thing put up here, and if you're outputting lots of stuff on here, this thing starts scrolling like mad and you can't see the wood for the trees. So my thought was that by having this sort of screen attached directly to the processor, all on one board without having to do anything much, it's driven by I2C, then you could put out messages like this. That top line there, in case you can't read it, actually says setup is okay, and the next one says Wi-Fi is bad. Unlike this one here where it says Wi-Fi ZZZ, which means I'm sleeping because I turn the Wi-Fi off when it's not needed. So these sort of things can just be put on this display and left there when you've got to a certain point in development. So I thought that would be really good, both for debugging and then in production, like this one almost is now. It can just sit there. I mean, obviously this date and time down the bottom, I don't need to display that, but you can imagine displaying that in the debug window. Every second you're going to get a new update. In fact, it's more than that. This gets updated probably, I think the code says 10 times a second. So if I was literally writing all this to the serial window, aka debug window, I'd get 10 of these a second, and if any of this happened up here, if any of this changed, you just wouldn't see it. So putting it onto a screen like this is very useful. I found it so anyway. So that's what I was doing over here. Now the library for this, obviously, okay, let's just unplug this now. Right, enough beeping for one day. The library for this obviously runs on an ESP8266 because that's what that is, and in fact it's the Adafruit library. And pretty nice it was too. It allows you to address any point on the screen. Now I've only got text on mine, but you can draw triangles, circles, lines, all sorts of different things, logos, bitmaps. You can do what you like. Now of course this is quite a small screen. I think it's 64 by, okay, I can't remember off the top of my head, but this one is 128 by 64, so quite a bit bigger, and therefore you can fit quite a bit more on it. Let's get rid of the blue tack. Right, so you can get quite a bit more on here. Now ignore the flickering as best you can. You can see that you can get a whole day in here, Saturday at 06 March. There's the time, and that is the correct time. Also, it's a pity you can't see this better, but I'll put a screenshot up so at least you'll get an idea from the phone. This is actually inverse, so Wi-Fi is bad, it says here, and it's written black on white rather than white on black to show that there's something wrong. That's the standard I've adopted for this project. Anything bad happens, it will be in white on black, inverse. Just that particular line though, not the whole screen. So I quite liked the Adafruit library, so I was a bit disappointed initially when I got this. The Adafruit library didn't work, not out the box anyway. One that did work, and you might still be interested in using this, is this one here. Right, so this is the library that works pretty much out the box actually, and gives you almost identical functionality to the Adafruit one. So this is ThingPulse ESP32 OLED SSD1306. Yes, you did hear me correctly. It does say ESP8266. It runs on the ESP32 as well. And if we just scroll up to the top of that page, you can see that it's ThingPulse over here. ESP82 blah blah blah. Right now, I don't think I needed to do anything other than follow the instructions on here. Usage, it's quite good instructions on here and how to use it and stuff. So we're using wire, in fact. That's I2C. Did you know that Arduino.cc, the people who made Arduino, realised after a while that they'd named their wire library wrongly? It should have been 2wire, but by then it was, you know, out in the wild, too late to do really. Anyway, so yeah, that all works. And if you just read all this through, I'll put this link obviously underneath my GitHub and in the video description, and you can play about with that. Look, it's all the features here: set color, set pixel. Well, color, don't get excited. It's either white on black or black on white. If you've got a black background, black on black doesn't work, and ditto white and white. Draw rectangle, fill. I mean, there's lots of things, and there's probably a demo program as well. Yeah, there's a whole lot of stuff there. Look, and you can freeze bits of the screen as well. So what they're saying here, for example, is that this bit down here doesn't change at 2054, 2054, but this bit up here does. Oh, and while we're here, left aligned, center aligned, right aligned, but only on one string. You can't put lots of things out there and hope it's going to align, because what it does is calculate the width of the string and then just, with maths, work out how much margin to leave. Okay, it's all pretty good, and that's what I got working initially. But then I found I couldn't do the white on black for a particular line, or a particular string, in fact, not even a whole line with Adafruit, it's just a string. So having seen that ESP8266 was mentioned here as opposed to ESP32, I looked at the original Adafruit one again. So it's slightly different to the one that I was using here, because this one is specifically for a small little screen like this, for the Wemos D1. Well, okay, let's say that correctly. The library has been amended by Adafruit to cater for a small little tiny screen like this, whether it's part of Wemos D1 or not. It's just this particular screen, and that works absolutely fine, isn't it? There's nothing wrong with that. And of course it's ESP8266. So when I saw that the other one worked for an ESP32, I thought, well, what's different then about the Adafruit one? Well, the first thing is, of course, that the I2C lines on here are not the standard 2122 that it's expecting. They're actually 5 and 4 SDA SCL. So the library doesn't expect you to change that. So I've tweaked the library a little bit. Although, to be quite honest, I'd expect Adafruit to do that any day by themselves if somebody else hasn't, because it wasn't difficult. And these boards are really, really good value at the moment. In fact, before we look at the code anymore, let's have a look where I got it from and how much it costs. Right, so I got it from here. Obviously, I didn't pay anything at all, but even at $6.86, you've got to admit that is pretty cheap, isn't it? So yeah, Banggood sent me this just for evaluation purposes. Jolly glad they did as well, because it really is a nice board. ESP8266 is considerably faster than the Arduino, and the ESP32 is considerably faster than the ESP8266. So it races along, and I'm not doing it justice at all by making it just display to the screen. In fact, that could be the cause of the flicker. Maybe it's updating the screen, 300 times a second for all I know. So yeah, it's exceptionally good. And so it says $975 there initially, 30% off, March 30th to April 30th. Well, it's March was it today, the 6th today, at the time of recording this anyway. So another week before it gets released. Well, you still would have a couple of weeks to get it at this good price. Now, if you're in the States, let me change this to dollars, and it's $8.89 as instead of $12.63. Now, interestingly enough, if you were to get it from the UK, that's the people who live in the UK. Obviously, you wouldn't get it from the UK if you lived in the States. It is $11.99. That's still not a bad price, actually. It's just full price, isn't it? No discount. But it's not bad. No, I'd get it from China because Banggood, as I say, seem to have their act together these days, and they ship stuff pretty quickly, so I'd be happy to get it from there. Yeah, so that's £6, whatever I said before, $8.89. And anything else to say about it on here? Oh yeah, it's got Bluetooth, of course, that the ESP3266 hasn't. So that'd be good. Don't need to add any shield or anything. Nothing else of interest for us anyway. So I'll put the link for that underneath my video description and in my GitHub. And let's think about the code again. Now, the first thing, obviously, you'd have to do in the Arduino world, because this isn't the Arduino IDE this time, as you can see, but it works exactly the same, no difference at all, is to include the ESP32 boards. So let's move away from this IDE and move over to the Arduino IDE so that you can see what you have to do to add in the boards first. Right, so this is the Arduino IDE all booted up. As you can see, there is the original sketch that I said with the pulse thing library being used, except it's called SSD1306 here. This bit here. But anyway, that's not the point. We want to see how we get those ESP32 boards in here. So it's pretty much like I told you last time. Go down to Preferences, and then in this bit here, let's make this a bit bigger so we can see what's going on. This last line, I'll put this in the video description and whatnot as well. Remember, you've got to be patient though. Having added this and then said, okay, you've got to wait and then wait again. And eventually you'll get down to Tools and you go to Boards Manager. And then wait for it to do all its stuff down here. Keep looking at this bit down here, which takes a little while, it must be said. So we'll come back in just a second. Right, and when it does finally wake up, you'll be able to type in ESP32 there and get this library available to you, but this boards library anyway. Now, I've installed 101 because I think that's the only one available now. Oh, 100, fine. Don't select that, select 101, click on Install, or if you happen to have the 100 already installed, click Upgrade, which is missing on this because I've got nothing to upgrade to. Anyway, do that, you click OK. I won't, because otherwise it will take even longer. Now you have to sit here again for a little while until these buttons at the top here become responsive again, because it's obviously downloading loads of stuff. Right, I'll go and make a cup of tea, I think, and be back in just a few minutes. Oh, right, you caught me red-handed there. That wasn't a cup of tea after all, no. Right, so it's back. So now you say Tools, Boards, and I've selected WeMOS Lowlin32 because that made the most obvious sense. But if you scroll down this big long list, and as I said last time, I've got a longer list than most, and I'm not boasting, because I've got so many different types of board that I'm playing about with. So there we are, WeMOS Lowlin32, and that's the one that works. It'd probably work if you did Lowlin32, or I don't know what the Pro version is deliberately. Anyway, that's fine. And you do that, all these defaults here will automatically come up, I believe. In fact, there's fewer of them, isn't there, for the ESP32. So upload speed 921/600, nice and fast. That sorts out the bad USB cables from the good, apparently. 80 megahertz flash. Partition scheme default. I don't know what, it's a pity it doesn't tell you what the default is, isn't it? What does default mean? Yeah, I know it means out the box, but what is out the box? This one, no over-the-air large apps. That means all the memory is being used by your program. Or minimal spiffs, large apps still with an over-the-air update capability. We'll have to talk about that one day, won't we, the ATA stuff. Port, well, the port, whatever your board is on. Mine's on 17, and that's it. And then you can create stuff for the ESP32, and it's all fine. Now, there is one little thing quite annoying with this particular board. So let's go back to the desktop. On the back of this board, as you can see, there are two buttons. I don't know where my pointer's gone this week. Seems to have disappeared. Nope, it's gone walkabouts. Okay, so there's two buttons on the back here. One says boot and one says N, or EN, you know, enable I suppose. And the boot one is the one you have to press in order to upload code to it. So given that we have this code here, I'm going to keep my finger close to but not actually pushing this button yet. Now if I want to update this, because I don't think there's anything more to be said about this particular code apart from the fact it's, well, to you it looks like it's flickering, but believe me, to me it's pin sharp, rock solid, beautiful. And just to prove the point, I've tried two different font sizes, but I'll come on to the sketch in a sec. There's a rather nice bit of that sketch that you'll think, what? Anyway, so I'm going to keep my finger on the boot button and I'm now going to try and upload this to the board. Let's have a look. Right, it's trying to connect. So I need to press this button. Hold it, and there it goes. Excellent. That's going to upload quite a few bits actually. So yeah, there's the main code, and that's hard resetting. And oh, look at that, initializing it says. Now, there's something I've noticed about that straight away, and you two have as well, I imagine. It's not flickering. That means it must be something to do with the library I'm using. Ooh, never knew that. Well, now you can see how good it looks. If I get rid of the code window and bring it center screen and try and zoom in on it a little bit. Yes, that's not too bad at all, is it? That's showing it much more like it should be. So I wonder what the Adafruit library is doing that the other one wasn't. They both look exactly the same in real life, except this one looks 1,000 times better on screen. Well, who would have thought? Right, enough of this. Let's talk about the bit of code that I wrote, then look at the Adafruit one, the changes, more to the point, I had to do to make it work. Because although, yes, it flickered, it doesn't flicker like that all the time. Cool. Right, I've fired up, yes, the Eclipse IDE, just because it's easier for me to show you stuff on screen. But apart from that, this sketch would work just as well in the Arduino IDE as the other one did. So I just want to show you a couple of things then. The first thing, of course, is that on the serial monitor, the debug screen over here, you're seeing that the time's coming up every second. That's what I'm talking about, having a built-in screen. We wouldn't need to do this. If you were debugging this, instead of it coming up in the debug window, pushing everything else that might be coming up on here as well off the top of the screen, you can simply display stuff now on screen. It's great to do that. Anyway, we'll ignore this and try not to get distracted by it, because I want to show you a few things in the actual code. Right, the two libraries you need are these two here. There is a special library for the Wemos D1 mini screen, the Adafruit, but and it's slightly updated. I'm sure the two will sort of merge eventually, but this is the one to use for the time being. Config, yeah, okay, blah de blah de blah. Now, the two differences here, the two pin differences, are because the screen is built into the module, not separate. We're not using the standard ESP32 I2C pins, which is 21, 22. We're actually using 5 and 4. I don't know why that is. It's obviously just built into the board that way. So it's very important that you define them here, because I've had to change the library, and I'll put this changed library up onto my GitHub so you can download it and have a look, and then either use that one or make your own amendments. Now I reckon that Adafruit will probably include this eventually in their library. I'm not going to fork the library, as it's called, you know, make a new version of it for them to then merge. I don't think it's worth that. So just declare your pins here. These are all my forward declarations. You don't need to do that in the Arduino IDE. It's more forgiving. Right, so here, this is the new method that I've implemented, just to tell it which pins you're using for the I2C. All right, and I'll show you how that's done in the library. It's literally a 2-second edit. And everything else is standard. This is probably all coming from one of their examples, I should think. Oh yeah, this one isn't. The rotation, as you can see, on screen, I've actually got this board with the processor on the right. It just works better for me that way, with the lead on the left, and then also the reboot button is at the top, so it's easier to grab hold of. If this were the other way round, like that, then the button's down the bottom, it's awkward to get to, but of course the writing's upside down, in which case you'd set that display rotation to, well, not put it in at all because the default's 1, which is the other way around, or specifically say it's 1. Okay, anyway, you can play with that. Screen text size 1. Well, that's the tiny text on there. If you look at the Sunday, April the 7th bit, and the funny looking time right at the bottom, that's all text size 1, and the big time in the middle is text size 2. Okay, I know this is a different sketch we're running here, but it was the first one that you saw, and it's all pretty similar. Okay, you can. The lovely thing I do like about the Adafruit is you can set the cursor. This is the actual pixel point. So 00 is top left, and each character at text size 1 takes about 8 little dots, little pixels. So the next one would start at either 8 or 9, and you can play about with that and position things absolutely spot on, whether that's text or a line or a circle or whatever. That's one of the reasons why I took this particular library. You must say display.display. I know it sounds a bit silly. They could have used a different method name there, couldn't they? Like show or something, display.show. I mean, you can rename it, nothing's stopping you doing it. But if you don't do that, it won't copy the buffer where all this stuff is being put onto the actual screen. You'll end up with nothing. So do not forget that. Okay, so this is just displaying a few bits. Now, the bit that's changed in this whole sketch is this bit here. Now, if you remember in the previous sketch, that one on screen there about the NTP server and all that, this replaces all that, except that, as we saw, it's an hour out at the moment. But basically you say config time, blah-de-blah-de-blah. I've got that as 0, GMT offset. Daylight offset, I've also got a 0. But really, we're sort of an hour ahead in the UK at the moment, so maybe that's what the problem is. But I didn't want to adjust this. I don't want to have to change the code every time we have a daylight saving operation. And the NTP server is declared at the top. That's the uk.pool.time.org or wherever it is you are in the world. Now this bit down here should have set my time zone and the daylight saving. And when we reboot this, it does do all this properly. But overnight, obviously, it's got it wrong. Yeah, something happened overnight. I don't know what to make that go an hour late. Well, in fact, it's showing GMT time. That's what it's showing rather than British summertime, which should have been declared by this BST month 3. I don't see that. This is why I'm not explaining all this yet, because I haven't had a chance to look at it. Somebody put it up on the previous comments, say this is the way to do it. So I've had a play, and it's sort of okay, but I haven't really cracked what all this is about yet. You can sort of work it out, you know, when it starts and when it finishes, but I really need to dig deeper into that before I present that. So the only difference here is, let me see, if it doesn't get the time, it waits a second and then continues round this loop until it does get the time, because if it doesn't get the time, there's no point even continuing. And if it does get the time, it goes and grabs it, puts it into a struct. Now, if you don't know what a struct is, I'll put a link on the bottom. Basically, it's just a way of organizing the data so you can easily get it back out again. It's simple to do, very easy, and very worthwhile learning how to use. And then we disconnect the Wi-Fi and say, that's it, we don't need it anymore. And this is in fact what I do on my Home Alone project as well. So that one at the back, I only ever switch the Wi-Fi on when it's needed. One, it saves power, but more importantly, the Wi-Fi does interfere with some other operations if you're not careful. So probably best to switch it off, given that I only need it once an hour on that one at the back. Why have it on for the other 59 minutes? So the loop, all the loop is doing is saying, go and update this display every 100 milliseconds. That's all it's saying. Why am I doing it like that? Not every nanosecond? Well, because in that sketch at the back there, I do lots of other things as well. So I don't want to spend time updating a display that doesn't need updating, because it must take time to copy that buffer to the screen every time. I prefer to then skip over this and do other stuff like checking for movement. See that flash? That means we had a bit of movement and things like that. Okay. Connect to Wi-Fi. I'm certainly not talking about that, although it does display, as you can see here, look. it displays here whether or not the Wi-Fi is connected, which you can see better on this one at the back here actually, because that is the code. So Wi-Fi. Now I've got ZZZ because it's sleeping, but if I were to reboot this, initially it would go to wait, then OK, and then finally sleeping. Or it'd say bad in black on white to show that there was an error. Okay, now print local time. Okay, we can print it to the serial port. That is the debug window over here again, of course, but I'm choosing not to because it took quite a bit of time to do that, even though we're running at 76800 baud rate. So what we are doing is displaying the date and time here, which is the very next routine. So it's this one here. Okay, I've put this in again, just because that's how it is in my original code for that. So just ignore that because we know the Wi-Fi is off, don't we? And grab the time again every now and again here, but once again we'll ignore that and then display it. Now in the original sketch that I showed you, to display a single integer with 2 digits always, so for example if the hour, like now being shown here, is 08, what we don't want is it to be shown as a single digit like this one is down the bottom. If you look at the bottom line there on that display, it's just showing it as 8, isn't it? We don't want that. We want always as a leading 0 or 2 digits. And this basically shows you a way of doing that, and also a better way of doing it, a C++ way of doing it, if you will. So we're using Printf, which stands for string print formatted. You can read up about that, just do a Google search, but basically this little string in the middle, how you want it to be displayed. So this integer value here, time info, that's the struct, .tmsec, that's the seconds. I want it displayed as 0, leading zeros, 2 digits, and it's decimal. Now, as it's a positive number, I could have put %02u, which is unsigned, because if it's decimal and it goes negative, it will put a sign in front of it. Okay, and then it just displays it, sets the text size back down again to 1 because we're on 2, and that's it. This is the old way of doing it. This is the, I don't know, the sort of, I don't know what way you'd call it, but basically it says if the value you're trying to display is less than 10, that is a single digit, it displays a 0 first. Quick, easy, just for hacking about, that's not a problem. But as I say, it's nice to be able to use some of the C++ functions. Actually, now there's a thought. Does that work on the Arduino IDE? Yes, it must do, because I've had this running on it. So there we are. Right, okay, that's it then. So this board with the ESP32 plus this SSD1306 works really well with the Adafruit library. The one little change you've got to make is this. You go to the Adafruit CPP file, C++, and the change you make, oh good lord, is the new function that I've made. So down the bottom here, if I can expand it, there we are. All it does is take the 2 values that you've put in and put them into local values, and those 2 local values are declared in the header. I'll tell you what I'm going to do. I'm going to put the whole thing in the library, in the GitHub, and in the sketch details, so that you can have a read of this. But you can grab it and follow it through. It's really, really simple. Believe me, it just looks a bit overwhelming at the moment because, you know, all this stuff over here. This is a library that most people really don't get their hands dirty with, but this is very, very easy to do. Right, I think we've sort of come to the end of this now. I've probably gone rabbited on far too long. Let's upload the sketch that's on the screen now to this and watch it all flicker away again. I wonder why it's doing that, but not in real life. Let's make it quite clear. In real life, it looks as sharp and as clear as this. It's only on my video camera that things look a bit wonky. Right, I've now got to press that button at the top again. So off we go. Hold it until it says something on screen. There it goes, and you can let go. And eventually we'll see a different sketch appearing on here. Won't be initializing. There we go. So this is the original sketch, flickery flickery. And look, the time's back to normal. And I don't think it's the, well, it's got nothing to do with the actual code. It's the way I'm doing that set env command that's determining what's happening here. So I've obviously not quite got something right there. Okay, but as I say, flickery flickery only on screen. To me, looking at it in real life, pin sharp, very nice screen indeed, and you can get quite a lot on it because it's quite large, isn't it? 128 pixels across, 64 deep, and for that price, just have a quick look back again where I got this from. All right, here it is. Now this is the UK price in dollars, which doesn't make a lot of sense, so let's change that to pounds. British pounds, there it is. So that's, when it comes back, does it say 926? Yeah, 926 if you buy it directly from the UK. And then, of course, you'll get it within, as it says there, 1 to 3 business days. But if you buy it from China, they got a special offer. And £6.86. And it'll take between 7 and 20 business days to get to you, which isn't that long. So, pays your money, takes your choice, as they say. In dollars, you want this in dollars from China? Fine, let's do that. So $8.89, that's going to say, from China. And that's a special offer until the April the 30th. Cool. Right, okay. Right, I think we've pretty much covered it then. I'll leave that with you, put some extra stuff. I'll put the data sheet for the SSD1306 screen, OLED screen, in my GitHub as well, so you have a good read if you want to delve that a little bit deeper. And, well, good luck with playing about, because I think this is really worthwhile, must admit. Okay, thanks for watching. Do put some comments underneath. You know, YouTube love that. I like reading them. Other people like reading them. If you've got any comments regarding that setenv command, that obviously I'm doing wrong somewhere, please feel free to chip in. I don't mind a bit of help, but otherwise I'll just investigate and present that in a future video. Alright, thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.